To fix this Radeon HD6850, we ended up modifying the critical temperature fault circuitry and replaced the low dropout regulator. As mentioned in a previous video, I typically buy defective video cards from various auction sites in an attempt to fix them. The ad featured two what were labeled untested cards, a GT8500 and the HD6850. At least in my part of the world, untested means defective, but I'll pretend I don't know for sure. I suspect that the 8500 was thrown in to justify the 10 USD price. Actually quite high for a broken HD6850. Resistance measurements at both 12 volts and 3.3 volts on the PCI fingers didn't reveal any issues. Measuring resistances between ground and various through-hole inductors also showed no shorts. Same for the external 12 volts power connector. All seemed okay, so I slotted the card and powered it up. No voltage was present. My repair notes have written down, this may all boil down to the GPU VDD enable. Optimistic for this one. The phase controller used for the GPU voltage is an APW7088. It uses just two phases, one phase powered from the 12 volts from the PCI fingers and the other phase from the external 12 volt supply. Having access to the datasheet of the phase controller, I made a list of voltages to check. VCC, 5 volts VCC, power OK, mode, feedback, soft start. VCC and 5 volts VCC measured OK, 12 volts and 5 volts respectively. All others, however, measured close to zero. The datasheet mentions that the soft start pin, SS, needs to be higher than 0.5 volts in order for the controller to run, so it appears we have found the issue. I used the multimeter in continuity mode to find what components are connected to the SS pin. I expected some transistors that would act as power sequencing circuit. Q1008 and Q210 had their collectors connected to the signal. If any of these would be opened, they would pull low the slow start signal. Still in continuity mode, I proceeded to trace the partial schematics of the circuitry that drive the slow start signal, and it seems that Q1008 is the final stage from the circuit that makes sure that all power rails are present before powering the GPU. Q210 seems to be driven by a latch made out of Q209, a PNP transistor, and Q215. These kind of latches are used for critical temperature faults, and the behavior here is to shut off the GPU and power the fan 100%. Having this knowledge, I powered the card once again and paid closer attention to the voltages. And funny enough, I noticed that the slow start line does pop off high for a brief moment, but then goes low. The power sensing circuit was behaving okay, and judging by the base of Q210 being high, it was the CTF circuitry that seemed to be acting up. I considered disabling the circuitry, and I did so by shorting the pads labeled R241, a resistor placement between the emitter and base of the PNP transistor. Back to the mining adapter, I powered on the card, and yes, the slow start signal stayed high, and we got GPU power and memory power and VDDCI voltages. Even one of the LDOs, U350, was outputting 1 volt. Yet we had no picture. The repair notes state that there is another LDO, U300, that I needed to check as well. I left aside that investigation and prioritized the behavior of the critical temperature fault circuitry. While shorting the base of the PNP transistor to the emitter will power up the card, it will also disable the CTF functionality, and I didn't like that. Rummaging through the schematics that I have, I noticed that the CTF circuitry I was reverse engineering looked very much like what MSI uses for some of their Polaris cards. The resemblance was quite deep, to the point that even transistor labels and resistor labels matched the HD6850. I noticed that MSI uses a 13K resistor for R241 just to make sure that the CTF latch doesn't go on into power up, but high enough that when the GPU does go into CTF, the signal it sends can turn the latch on. I looked up a 30K resistor on my favorite donor board, the GTX 960, but while the schematics did show a few candidates, the PCB had just empty pads. Considering the purpose of the resistor, I figured any resistor between 10K and 18K might do, with a preference to the lower value, to keep the latch turned off. So I searched for a 10K resistor and a couple of promising candidates showed up on both the schematics and on the PCB. Resistor 719 and 761. I then replaced the short on the pads of R241 with a 10K resistor harvested from the donor, and once again the card powered up and stayed powered up. I therefore graded the CTF circuit as fixed and went on with the voltage measurement on the LDO that I skipped the previous time. And the voltages that I got were weird. The output was 0.7 volts, the feedback voltage was 0.3 volts, and the power OK signal was low. Now, according to the datasheet, the LDO used here has a 0.8 volts reference, so measuring 0.3 volts on the feedback pin was a dead giveaway for a bad LDO. But I did not have a replacement for the APL5920. However, as I was going through the datasheets that I downloaded, I noticed that another LDO, the UP7701, had not only the same pinout, but also the same reference voltage. The UP7701 would then be a drop-in replacement for the NPAC LDO. The problem is, the 7701 didn't show up on either the GTX 960 or on the Lenovo motherboard. However, the GTX 960 also had an LDO, a 7103, and lo and behold, its datasheet confirmed that it could also be used as a drop-in replacement. Encouraged by this finding, I took the time to search for all the SO8 chips on the Lenovo motherboard and look up their datasheets, and sure enough, I found that the two chips labeled as NCT3730S are also LDOs, and yes, they can also be used as drop-in replacements. There was only one thing to do. I desoldered the bad 2 amps NPAC chip from the 6850. I also desoldered one of the Nuvoton chips from the Lenovo motherboard. I then soldered in place the 3 amps LDO from Nuvoton onto the PCB of the 6850. And if you kept an eye on the video playback progress, you know we're getting close to the end. I slotted in the card in the mining adapter once again and powered the PC. And yes, the card did output an image. After reassembling the card, I then slotted in my PC. Drivers installed just fine, GPU-Z did list all its parameters properly, and Heaven ran fine.